Top 25 Java Microservices Interview Questions and Answers. Java microservices have become a popular architecture for building scalable, flexible, and cloud-native applications. Organizations increasingly use Java frameworks such as Spring Boot and Spring Cloud to develop independent services that communicate efficiently. Preparing for Java microservices interview questions helps candidates understand core concepts like service discovery, API gateways, load balancing, fault tolerance, containerization, and distributed systems. This guide presents 25 commonly asked Java microservices interview questions with clear, professional answers to help both freshers and experienced developers perform confidently during technical interviews and secure their desired software development role. 1. What are Java microservices? Java microservices are an architectural approach where an application is divided into multiple small, independent services. Each service focuses on a specific business function, runs independently, and communicates with other services through lightweight APIs such as REST. Java frameworks like Spring Boot simplify microservice development, while Spring Cloud provides tools for service discovery, configuration, and communication. This architecture improves scalability, flexibility, fault isolation, and deployment speed compared to traditional monolithic applications. 2. Why are microservices preferred over monolithic architecture? Microservices are preferred because each service can be developed, deployed, and scaled independently without affecting the entire application. Teams can work simultaneously on different services, reducing development time. If one service fails, the remaining services continue operating. This architecture supports continuous integration and deployment, making applications more resilient, maintainable, and adaptable to changing business requirements while improving overall performance and system reliability. 3. What is Spring Boot in microservices? Spring Boot is a Java framework that simplifies microservice development by providing auto-configuration, embedded servers, and production-ready features. Developers can quickly create standalone applications without extensive configuration. Spring Boot integrates seamlessly with Spring Cloud, making it easy to implement service discovery, configuration management, monitoring, and RESTful APIs. Its simplicity and productivity make it the most popular framework for building Java microservices in modern enterprise applications. 4. What is Spring Cloud? Spring Cloud is a collection of tools designed to simplify the development of distributed systems and microservices. It provides features such as service discovery, centralized configuration, API gateways, circuit breakers, load balancing, and distributed tracing. Spring Cloud integrates smoothly with Spring Boot applications, allowing developers to build scalable, resilient, and cloud-ready systems while reducing the complexity of managing multiple, interconnected microservices in production environments. 5. What is service discovery? Service discovery is the process of automatically locating microservices within a distributed environment. Instead of hard-coding service locations, services register themselves with a discovery server like Eureka. Other services query the registry to find available instances dynamically. This approach supports scalability, load balancing, and fault tolerance because services can be added, removed, or updated without modifying application configurations or affecting client communication. 6. What is Eureka Server? Eureka Server is a service registry provided by Netflix and integrated with Spring Cloud. Microservices register themselves with Eureka when they start and periodically send heartbeats to indicate availability. Client applications use Eureka to discover service instances dynamically instead of relying on fixed URLs. This improves flexibility, supports dynamic scaling, simplifies service communication, and enhances the resilience of distributed Java microservices architectures. 7. What is an API gateway? An API gateway acts as a single entry point for all client requests in a microservices architecture. It routes requests to appropriate services while handling authentication, authorization, rate limiting, logging, request filtering, and load balancing. By centralizing these responsibilities, the API gateway simplifies client interactions, improves security, reduces network complexity, and allows backend services to focus entirely on business logic and application functionality. 8. What is load balancing in microservices? Load balancing distributes incoming client requests across multiple instances of the same microservice. This prevents any single instance from becoming overloaded while improving application performance and availability. Spring Cloud Load Balancer helps automatically distribute traffic among available service instances discovered through Eureka. Effective load balancing enhances fault tolerance, supports horizontal scaling, ensures optimal resource utilization, and delivers a better user experience during high traffic periods. 9. What is a circuit breaker in microservices? A circuit breaker is a fault tolerance pattern that prevents repeated requests to a failing service. When failures exceed a defined threshold, the circuit opens and temporarily blocks requests, allowing the failing service time to recover. Frameworks like Resilience 4J implement circuit breaker functionality in Java microservices. This approach improves application stability, reduces cascading failures, and enhances overall system resilience in distributed environments. 10. What is REST communication in microservices? REST communication is the most common method for enabling interaction between microservices using HTTP protocols. Services exchange data through RESTful APIs using methods like GET, POST, PUT, and DELETE. Data is typically transferred in JSON format because it is lightweight and easy to process. REST is platform-independent, scalable, and simple to implement, making it an ideal choice for communication between Java microservices and external client applications. 11. What is inter-service communication? Inter-service communication refers to the exchange of data and requests between microservices. It can be synchronous using REST APIs or asynchronous using messaging systems like RabbitMQ or Apache Kafka. Synchronous communication provides immediate responses, while asynchronous messaging improves scalability and reliability by allowing services to communicate without waiting for each other. Choosing the appropriate communication method depends on application performance, consistency, and business requirements. 12. What is configuration management in microservices? Configuration management centralizes application settings so that multiple microservices can access shared configurations without storing them locally. Spring Cloud Config Server provides centralized configuration management by storing configuration files in repositories like Git. This enables developers to update application properties without rebuilding services. Centralized configuration simplifies maintenance, improves consistency across environments, enhances security, and supports dynamic configuration updates for distributed applications. 13. What is Docker and why is it used with microservices? Docker is a containerization platform that packages applications with their dependencies into lightweight containers. Each Java microservice can run inside its own Docker container, ensuring consistent behavior across development, testing, and production environments. Docker simplifies deployment, improves portability, reduces environment-related issues, and supports efficient resource utilization. It works exceptionally well with microservices because each service remains isolated while being easy to deploy independently. 14. What is Kubernetes in microservices? Kubernetes is an orchestration platform used to automate the deployment, scaling, monitoring, and management of containerized applications. It manages Docker containers by ensuring desired service availability, performing automatic restarts, load balancing traffic, and scaling applications based on demand. Kubernetes simplifies the management of large microservices environments, improves fault tolerance, supports rolling updates, and minimizes downtime during application deployment or maintenance activities. 15. What is fault tolerance in microservices? Fault tolerance is the ability of a microservices application to continue operating even when one or more services fail. Techniques such as circuit breakers, retries, fallbacks, redundancy, and load balancing help prevent failures from affecting the entire system. Fault-tolerant applications provide better availability, improve user experience, reduce downtime, and maintain business continuity despite network issues, hardware failures, or temporary service outages. 16. What is distributed tracing? Distributed tracing tracks requests as they travel across multiple microservices within a distributed application. It helps developers identify performance bottlenecks, latency issues, and service failures. Tools such as Zipkin, Jaeger, and OpenTelemetry collect tracing information and visualize request flows. Distributed tracing significantly improves debugging, performance optimization, and monitoring by providing complete visibility into complex service interactions across the application ecosystem. 17. What is centralized logging? Centralized logging collects logs from all microservices into one location for easier monitoring and troubleshooting. Instead of checking individual service logs separately, developers use platforms like the ELK stack, Elasticsearch, Logstash, and Kibana, or Grafana Loki to analyze application behavior. Centralized logging improves debugging efficiency, simplifies issue diagnosis, enhances security monitoring, and provides valuable operational insights across distributed Java microservices environments. 18. What are the advantages of Java microservices? Java microservices offer numerous advantages, including independent deployment, better scalability, improved fault isolation, faster development, technology flexibility, and easier maintenance. Different teams can work on separate services simultaneously, increasing productivity. Individual services can scale according to demand without affecting others. Combined with Spring Boot, Spring Cloud, Docker, and Kubernetes, Java microservices enable organizations to build reliable, cloud-native, and highly available enterprise applications. 19. What are the challenges of microservices? Microservices introduce challenges such as increased operational complexity, distributed data management, network latency, service communication, monitoring, security, and deployment coordination. Managing numerous independent services requires robust DevOps practices and automation tools. Developers must also handle versioning, fault tolerance, and distributed transactions carefully. Although microservices offer significant benefits, organizations need proper architecture, monitoring, and infrastructure to successfully implement and maintain large-scale distributed applications. 20. What is database per service pattern? The database per service pattern means each microservice owns and manages its own database instead of sharing one with other services. This approach ensures loose coupling, independent deployment, and better scalability. Services communicate through APIs rather than directly accessing another service's database. Although data consistency becomes more challenging, this pattern improves service autonomy, simplifies maintenance, and supports independent evolution of each microservice over time. 21. What is an event-driven architecture? Event-driven architecture enables microservices to communicate by publishing and consuming events instead of making direct synchronous requests. Message brokers like Apache Kafka or RabbitMQ deliver events between services asynchronously. This approach improves scalability, reduces service dependencies, and increases system resilience. Event-driven communication is especially useful for applications requiring real-time processing, high throughput, and loosely coupled interactions between multiple distributed services. 22. What is API versioning in microservices? API versioning allows developers to introduce new API features without breaking existing client applications. Different API versions can coexist, enabling gradual migration to newer implementations. Common versioning approaches include URL versioning, request headers, and query parameters. Effective API versioning ensures backward compatibility, minimizes service disruptions, supports continuous application evolution, and provides flexibility when updating business functionality in Java microservices environments. 23. What security measures are used in Java microservices? Java microservices use several security mechanisms, including HTTPS encryption, OAuth 2.0, JWT authentication, Spring Security, API gateways, and role-based access control. Sensitive data should always be encrypted during transmission and storage. Authentication verifies user identity, while authorization controls access to resources. Regular security updates, input validation, logging, and monitoring further protect microservices against unauthorized access, data breaches, and common cyber threats. 24. How do you monitor Java microservices? Monitoring Java microservices involves tracking application health, performance, resource utilization, and system availability. Tools like Spring Boot Actuator expose health endpoints, while Prometheus collects metrics and Grafana visualizes performance dashboards. Distributed tracing and centralized logging complement monitoring by identifying bottlenecks and failures. Continuous monitoring helps detect issues early, improves troubleshooting, optimizes performance, and ensures reliable operation of production microservices. 25. What are the best practices for building Java microservices? Best practices include designing small single-purpose services, implementing centralized configuration, using API gateways, enabling service discovery, securing APIs, applying circuit breakers, containerizing applications with Docker, orchestrating deployments with Kubernetes, monitoring system health, and automating CI/CD pipelines. Developers should maintain loose coupling, comprehensive testing, proper documentation, and independent databases to build scalable, maintainable, resilient, and production-ready Java microservices applications. Java microservices have transformed modern software development by enabling scalable, flexible, and resilient applications. Understanding concepts such as Spring Boot, Spring Cloud, service discovery, API gateways, Docker, Kubernetes, distributed tracing, centralized logging, and security is essential for succeeding in technical interviews. By mastering these 25 Java microservices interview questions/answers, candidates can confidently demonstrate their knowledge of distributed systems, impress interviewers, and increase their chances of securing Java developer and microservices engineering positions in today's competitive technology industry.